Okay, so today in this video, we're looking at 12.2, which is our measures of central tendency. And let's recall what we learned in 12.1. 12.1, we learned that we can have a bunch of numbers, right? It's just a whole bunch of numbers, right? We have all this data. We learned with this data, what we can do is we can make a frequency distribution table, right? We can make a frequency distribution table. And we learned that with this frequency distribution table, what we can do is we can make a histogram, right? Or we can make a frequency polygon. Right, so these are things that we did in 12.1. We even learned that another option is to make our stem and leaf plot, right? Where this is the stem and those are the leaves. So with all this data, right, we can do these different things to help visualize our information. What we're going to do here is we're going to take a look at these numbers, right? We're going to say that our numbers are represented, let's say these numbers, I'm sorry. Numbers in statistics representing sometimes what we call the average are known as the measures of central tendency, which is what this section is about. All right, these measures of central tendency are generally located towards the center of a distribution. And that's really important to understand, right? Located towards the center, right? So let's take a look at maybe a frequency distribution table, right? We know that here is the smallest data value. We know that there is the largest, right? Somewhere right in there is the center, right? Same case with a histogram, right? Or a frequency polygon, right? If we have something like this, right? Somewhere right around there is also the center, right? So once again, that is the measures of central tendency, which is usually somewhere known as the average. So what are the measures of central tendency? We have 4 measures of central tendencies. Right, we have the mean, the median, the mode, and the mid-range. So we have 4 measures of central tendencies, and what we'll do here is we'll start off by talking about the mean. So this mean, right, is the most common measure of central tendency. And it's found by adding all the numbers, right? By adding all the numbers or your data items, right? And then dividing that sum by the number of data items. All right, so let's take a look here. We say that the mean is found by adding all the data items and then dividing, right? Our fraction line is division, dividing by dividing that sum. You add all the data items. Once we add that, right, we divide that sum by the number of data items. So this is, in words, how we find the mean. But we can also use symbols to show this, right? The mean can be represented two different ways. It can be represented by this X with the line over it, reads X bar. Or it can be represented by what looks like to be a cursive U, but this is a Greek symbol. And this is mu, right? So this is a Greek symbol. And they'll use it two different ways dependent on the problem. It could either, if the problem is talking about a population, they'll use mu. If it's talking about a sample, they'll use X bar. So you can see it either way. Adding all the data items, the top part, right? How we can show this is by also a different notation. Looks like an E. It's a Greek letter, right? You might have seen it in fraternity, sorority, something like that. We show it like this, right? Adding all the data items can be shown in this form. This symbol also means summation. That's really what it means. It means summation. So we'll see this again in our next section. So the summation of X, we're summing all the X values. And our number of data items, that is just a lowercase n. So what we can say is our mean X bar is found by the summation of X over n, right? Instead of using words, we can use symbols. Once again, they both mean the same thing. I do want you familiar with these symbols because we'll be using it at 12.3 as well. But the mean, nonetheless, very easy. Let's just add all the data items and then divide by the number of data items. Example. Find the mean. We have 11, 6, 4, 0, 2, 1, 12, 0, 0. Right, so it's 11, 6, 4, 0, 2, 1, 12, 0, 0. Okay, so our mean is found by adding all of our numbers and then dividing by the number of data items. Well, how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. Sorry, comma, 9. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this right here tells us that there's 9 data items, which is our n. So 9 goes in the bottom. So let's add the numbers on the top. All right, we have 11 plus 6 plus 4 plus 0 plus 2 plus 1 plus 12 plus 0 plus 0. We get the top to be 36. And then from there we just divide. So 36 divided by 9 gives us our mean of 4. So a nice first example of finding the mean here. And on our next video, we'll take a look at other examples of finding the mean.